really only about, I think 5 sections. And most of the sections are very similar. As you can see, I've already kind of planned out for today to kind of get into section 4.1 and bits of 4.2. I don't foresee that being an issue whatsoever to get started into both those sections. Tomorrow we'll continue our discussion on 4.2 and then lead into 4.3. Now, what happens within matrices is that we start dealing with stuff like this. Reference, you like that? I've never seen the movies.
Why?
Watch that.
Yeah.
First, we need to see the film.
Yes, sir. Get out, yeah. All right, so here's what we're talking about. Today we're talking about matrices. Matrices are ways to collect data. Matrices are a way to put a bunch of values together in a given form. What you can use matrices for is, like I said, it's a way of collecting stuff. We denote matrices by capital letters. We say matrix A. We have what are called rows and columns. Rows, think about you're rowing your boat across gently down the stream. Merrily, 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 while you're trying to hold up the columns. So in this case here, this matrix A would be considered a 2 by 3. 2 rows, 3 columns. That's what you look at it as. The values that are within the matrix are called entries. And as we get further along, you're going to find out that they mirror coefficients. Now, you are able to do many different operations within matrices. You can add them, you can multiply them, you can subtract them, you can do matrix equations, you can do a whole bunch of stuff. And all the properties of commutative property, associative property, distributive property, all those things all hold true. Now what's going to happen today though with these matrices, what we're going to do is just kind of start to get into the lingo with them. And I think the most complex part of today is going to be the multiplication. Now, I know your calculators will be able to do lots and lots and lots of matrix calculations for us. And that's fine. But I'm still going to hold you guys accountable to be able to doing some of this stuff by hand. Which means this is going to be our first test quiz sections that we're going to have 2 parts. Calculator, non-calculator. Now, when we get into the calculator versus non-calculator part, what we're going to see is that when you do certain operations of, I won't say addition, but multiplication, there's a process to it instead of just going with your calculator. So I want to make sure we all understand the process. Same thing with what's called a determinant. There are processes involved with it, but I'm always going to keep our values matrix themselves 2 by 3, 3 by 3s, things like that. Nothing too large and grandiose because it just takes too much time. Also, probably middle of next week, you will get your first extra credit project for this class. Now, what occurs with this thing is that I generally give I generally give a really large system that you have to crank out by hand. And it's usually about 4 or 5 pages of work. It's worth it. It's fun. I don't know what I'm going to do. I don't know if I'm going to change it this year, but this is kind of what I've looked at in the past. So we'll get there. Remember, you're dealing with rows and columns. Row, row, row your boat, and the columns hold things up. Hey, visual representation, not too shabby for a Wednesday. Don't worry about all this stuff. What I want you just to kind of to see here is they do have special names that do occur every once in a while. You don't see it very often. You have row matrices. That's just a matrix with 1 row. You have column matrices, a matrix with 1 column, and so on and so forth. A square matrix, you will deal with lots of those. 3 by 3, 2 by 2, 4 by 4, 5 by 5, and so on. It just means it's squared out. Zero matrices, hence why there are zeros. You will also come across something later on, and like I said, don't worry about cranking all this out, I'm just describing a few things that are here. One of the things that we will, don't write this down. One of the things you will see eventually is something called an identity matrix. An identity matrix is important in about 3 sections, about section 4.4. So there's just a couple of quick little vocabulary things. You don't see them very often. You might say, hey, you have a row matrix, a column matrix, square matrix. I will reintroduce matrices with word problems, probably middle of next week as well. That'll be one of the things that we'll build into this chapter. Since this is a very short chapter, matrices work really well with work problems, and so on. So let's take a look at some examples. Now, in order to be able to add or subtract matrices, they have to be within the same dimension. Now, when I'm talking about the dimensions of a matrix, they have to have the same number of rows and columns. For example, in this case, this would be a 3x1 and a 3x1. Can I add them together? Since I can add them together because they have the same dimensions, all you do is just match up the entries. So what's 3 plus 1? What's negative 4 plus 0? You may use your calculator if you want, but be careful if this is on a non-calculator part. You won't be able to fall back on, you might have to use your fingers for 7 plus 3.
Oh gosh, I forgot how to figure it out. Do we try that tomorrow?
Sure. We can sing the piggy song. 1 little, 2 little, 3 little fingers, 4 little.
I've never heard that. That's awesome.
Yes.
I think you should
Yes, it is.
continue in that song.
And that's what your final matrix would look like. Like I said, not so scary, is it?
Yeah.
Not yet. Now, what do you think you're going to screw up?
Lining them up.
Lining them up. Lining them up in the subtraction. Seriously, it's going to be lining them up in the subtraction part. Because what happens a lot of times is you guys get lost in a value. You forget which one you're matching up with what, or you'll forget what you're subtracting. You'll make a simple sign error. Okay? And B, can I subtract those two matrices? They have the same dimensions. They're a 2x2 square matrix. So your result would be 6, 10, 10, negative 1. And as you're doing problems like this out of your book, do you need to write out the original matrix as you're going through?
Yes.
No, you can go through like that. Yes, sir.
Why is the bottom left?
Because I added that one and I screwed up. See what you're going to do? You're going to go too fast and you're going to look stupid. I didn't do it wrong still. 3 minus negative 7?
I thought it was negative 3.
Because your hair is in your face, you can't see. I'll send you to my barber. And then the last one, can I add those two together? No. Nope, can't do it because they don't have the same dimensions.
So what do you write?
No solution. No solution. Can't do it. Not going to happen. Maybe next week. Maybe if they come up with a new way of doing math.
I'll figure it out tonight. and I'll let you
Let us know if it works.
know. We have to go with substitution.
Same thing here. When you're looking at, this is just scalar multiplication. It's distributed property. All you have to do is distribute and go. For example, in this first one, you're taking 3 times everything in the matrix. You don't have to worry about dimensions here because you're just distributing a 3. So your new resultant matrix would just be, well, all you're doing is scalar multiplication. Same thing with the other one. You think of it, bless you, you think of it as a order of operation style problem. You have multiplication before you can add. So you have to distribute the negative 2 into that first matrix before you can add the 2 together. Will I be able to add those 2 matrices together in the long run? Yeah, they're both 3x2 matrices, so you're going to be okay with that. So what happens here is you distribute out that negative 2.
You just do it to the first one.
Yeah, because it's not, unless it was re-bracketed like this. And then you would do this inside first and then go out. So what you're going to see is you're going to get order of ops problems. You're just going to get order of operation problems out of these things. That's a great question. So once again, as we get into that first one, is it the end of the world if when you're writing these things out that you don't put the brackets in as you're writing them sometimes? Especially if you're just going to be winding up to add things together. If you just scalar into one matrix, knowing that you're going to add to the new one, you know that your final answer is going to be, well, negative 2 and negative 4, 4 and 5, 0 and 6. You can do that math. And that's my answer. Okay, by all means, if you're working through these style problems, because matrices, they get kind of tedious to continually write things through. If you need to shortcut it through a little bit, it's not a big deal. It's not a problem. Just don't get lost in what you're doing. Okay? Like I said, this is a way of collecting and working with values. It's just another way of representing some stuff. Right? As we get further along, I'll show you what you can really do with these things. Yeah, you can do Excel programs with these. You can run all this stuff through Excel. It's kind of tedious. It's a lot easier to use your calculator. Solving systems of equations. Shh. Remember those 3x3s we did by hand? This is so much easier.
Are you kidding?
I thought we figured that out before I did that. Did you bring the rest or did you tell them to do it?
Well, yes.
Yes.
Because I would say solve it algebraically. And in order to solve it algebraically, even if you're using a matrix, you still have to use algebra to go through there, unless you've got a button on your calculator.
Do we have that button?
No.
Yeah, I have this button.
How much was your calculator? It was $1 million. Is it worth the button? Yeah, is it worth the button?
I have that.
You have one chapter that deal with matrices.
I have that calculator. Then I get a pass.
Now where it gets to be a little bit more interesting. Solving a matrix equation. And this is where I want to kind of work a little bit more today. Blow a second right there. I'm going to solve this for x and y. And I'll give you guys a second to write this out. I'm going to re-explain to you what this means. That's exactly what it means.
Second. That's what I heard. Close out, man. So if I send you an email right now, we'll do it.
Awesome. Yeah, I just wanted to give you guys a second to write this. It takes a second to write out matrices. Then I'm going to explain to you what this is asking us to do, besides solve for x and y. What you're trying to do here is you're trying to find a matrix that equals 26, 0, 12, 8. In order to have a matrix that equals 26, 0, 12, 8, the other matrix has to be 26, 0, 12, 8. All right? That's how you have equivalent matrices. Makes sense. Right, Connors?
Yeah.
Just asking. Don't email me. Don't email me.
I was gonna go on Skyward.
Oh, don't worry about it now. All right. So what happens here is you're setting up an equation. Now, here's what it's going to look like. Do we agree that you've got to take care of the order of operations within the parentheses first? So you have 2 outside, 3x plus 4, negative 1 plus 1, 8 plus negative 2, 5 minus y equals. Do you see where I'm going with this? Where am I going with this?
Two-step problems.
What's positive?
Oh, yeah.
Oh, thank you, thank you. Because now what happens is you're setting up this. 2 times 3x plus 4 has to equal, what is it? Ordering a pizza? What does this entry have to equal? 26. Because 2 times 6 is 12, and then the other one would be 2 times 5 minus y has to equal what? 8. Does everybody see how I did that?
I get it.
All we're doing, yeah.
Couldn't you do it where you distribute it and then 3x
Oh.
plus the are separate instead of just combining one. And then
Distribute the two to both matrices first? You can, but it's when you go order of operations, it's really easy to just take care of the inside first. That's technically where you're supposed to go. It still works. So now from here, it's just a matter of solving for x and y. And these are real fast, easy equations. 3x, was it 13? 13 minus 4 is 9. X is 3.
Yeah, like these.
What's that? And then for y is 1. And you're done. Yeah.
I also want to equality with the second parentheses, multiply both sides by half.
Absolutely. Another good idea. Could you multiply both sides by 1/2? Absolutely. Because over here, if you have a 2 here, if you multiply this by 1/2, the 2 goes away, you're going to wind up with this equals this, and it's just 1 less step. It's solving the equation with scalar multiplication. You guys all know many different ways of doing that. By all means, you can use any method that you like. I'm not going to yell at you. Okay? Remember, what's going to happen here is that you might just get lost in, like I did, and accidentally miss a sign, or you get lost in which entry you're looking at. Where are you in the actual matrix itself? Okay? Question about that? Not scary, is it? All right. Let's look at multiplying it. Let's blend this into 4.2. Yeah, you got a 10. Multiplying gets messy.
Are we gonna eventually get to dividing and then like
The divide, further away than I thought that. Dividing is just multiplying by a reciprocal in this case. You're just multiplying by a fraction. Because you don't really divide, you're not dividing matrices together. What we're doing here is we're going to be multiplying matrices times one another. You can't divide them. If you can, I don't know how. You might be able to. But in order to be able to multiply matrices, there has to be a specific pattern that occurs. What occurs with matrices, if you're going to multiply two matrices together, say we have matrix A times matrix B, the combination of the two would be matrix AB. Well, that means the number of rows has to equal the number of rows times columns equals rows times columns. The number of columns has to equal the number of rows between the two. That's the weird part. So, for example, if you have a 3 by 2, and a 2 by 2, if you multiply those two together, you have a 3 rows, 2 columns, 2 rows, 2 columns. You can multiply those two together because these are the exact same number. If those two weren't the same number, you can't do it. It's impossible to do. The result matrix is going to be the other numbers, the 3 by 2. This takes a little while to get used to. What you're looking at is rows by columns, rows by columns. These guys have to be the same, and then this is what the new matrix will be. After you do a couple of them, it's just a matter of simple multiplication problems. So if I have a 4 by 3, a 4 by 3 and a 2 by 4. Can I multiply those together?
No.
Nope, I can't. It won't work. But if I have a 4 by 2 and a 2 by 4, can I multiply those together? What would the result matrix be? 4 by 4. Okay. That's what this means. That means when you multiply the 4 by 2 and a 2 by 4, you'll end up with a 4 by 4. All right? And there's a nice nifty pattern that occurs when you do these things by hand. Am I going to have you multiply a 4 by 4 by hand? No. That takes up a lot of space. It's very annoying. 3 by 3? Kind of annoying. but not as annoying. 2 by 2s and 2 by 3s? Sure. Okay. I'm sure you're all excited and really waiting to figure out how you do this, right?
Yeah.
I can see the excitement in your eyes. Yay!
We're
Alright.
gonna run into the difficulty of 1 by 1s.
1 by 1s, I think you'll be all right with. So here's what happens. When you're dealing with multiplying matrices, oops, I missed this. We agreed this is a 2 by 2 and a 2 by 2, right? We agree on that? Okay. Can I multiply these together? What will the answer be? We all agree it's going to wind up being, these are the same, so these are the same, so it's going to equal a 2 by 2. I know that's what it's going to look like. As you first start to do these, take a brief second and write that down. That way you know what it should look like in the end. Now here's a little trick. Since we know it's going to be a 2 by 2, what I want to do is make a big bracket. It's going to be a 2 by 2, which means I'm going to have 4 entries. Okay. I'm going to write down this pattern. Notice how I wrote down the 3, 2, 3, 2, negative 1, 0, negative 1, 0. I wrote down that first matrix. I wrote it down twice, because I have to use it. Because that's how many I'm going to need. All right?
I don't know. Yeah, where are you getting this?
Okay. What happens is you take rows times columns. And it's a pattern that I found is easier to describe than taking row times a column. That gets a little bit messy. If I know I'm going to have 2 of them, if I know it's going to be 2 by 2, I'm going to write down that first one twice. Yes?
I think you messed up on the bottom row there, because you put the 0 in there.
It just, it really didn't matter which one we went into, but I see what you're saying. Keep it
Down.
the same. Yeah, I see what you're saying. Because what's going to occur here, 2. Now, in order to figure out what I've done, do you see how the next lineup of values, first entry, second entry, third entry, fourth entry, went boom, 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 boom. It just dropped right in. If you follow the pattern, and when we do a few of these, you will start to pick up on the pattern that evolves from this. It takes a couple of examples to see how it flows. Now, we start with that upper left. Can't write on the board with this one. 1, 1, 2, 2. Negative 4, negative 4. 1, 1. Now, my answer then is going to be what this equals. 3 plus 4. Negative 1 plus 0. Negative 12 plus 2. 4 plus 0. Once you break it apart, the arithmetic is a piece of cake. Remember, what we're doing here is we're writing down. You're writing down the first matrix twice because it's got to be it's going to be a 2 by 2, so you write it down twice. Okay. Since there's 2 columns, you write it down twice because there's only 2 columns. Now, all you do is you fill in the blanks. 1, 2, 3, 4. 1, 2, third one, fourth one. It's the pattern that flows through here. Granted, will I be asking you guys to try and do these 2x2s, 2x3, 3x2s, things like that by hand? Yeah. Can you do this in your calculator? Uh-huh. You want to know how you check it? Take your calculator out. I'll show you how you check this. That's a great picture. He's jumping into the corn pit. I just have to get the right time. I guess that's the only way you're allowed to enter a corn pit.
Okay.
Yes. You yell bonsai or whatever. Yeah, it's over at John Mack, you know that little corn pit they have there? Yeah, he was really excited about that. Just awesome. So we're slowly starting this thing out here. On your calculator, oh, you need a yellow one. Do you have a calculator? That's, make sure you find your yellow calculator. If we go to the button that's, you hit second, x to the negative 1, you'll see something that says matrix. Crazy. Now here's what we want to do. We're going to create two matrices. And what stinks about using your calculator with multiplying matrices, it takes forever to type in all the values. So you hit second matrix, it's the x to the negative 1 power. Now, I need to edit matrix A. We're going to call that 3, 2, negative 1, 0, matrix A. And we know it is a 2 by 2. And what's nice is if you type it in, you're not sure if it's like if it's 3 rows, 2 columns, or 2 rows, 3 columns. If you type it in, it'll show you where the entries are, so you know if you're right or wrong. Okay? Yes, sir. Second, x to the negative 1, and then move over to edit. Now I'm going to put in those values again. And it was, when you type in your calculator, if you hit enter, it moves to the right automatically. And then it goes down to the next one. And 0.
So then what do we do?
I'm putting in those entries. What I'm putting in right now is this first matrix. 3, 2, negative 1, 0. Okay. And like I said, when you're first using matrices in the calculator, it does take a lot of time to press these buttons. It's very tedious. Now back out. Second, quit. Mode. Go back in. That's your matrix. Right now, your matrix A is stored as a 2 by 2. That information is there, but we need to make another matrix. So we're going to edit and create matrix B. Hit enter. Once again, it's a 2 by 2. And our entries were 1, negative 4, 2, and a 1. And all I'm doing is just filling in the matrix in the calculator. All right? Back out. And now we have to figure out how do you multiply these together in your calculator. Well, second matrix A, second matrix B. Right now, I don't have that multiplication symbol in between the two because it is implied that when you put them together, they are multiplying. If you put the multiplication symbol in between the two, it doesn't hurt. Did you put the multiplication in between the two, or just put them right next to each other? Okay. What do you guys have? Yeah, quit. Yeah. Second quit. Mode. All right. And if you're not getting the same answer, what happens a lot of times, you might have missed an entry or something along those lines. Well, that's how you check your work on these things. All right, hit second, quit. Mode, right next to it. All right, now go second matrix. And you're doing matrix A times matrix B, so hit enter. Now to go back into matrix and go down to B. Just hit the arrow. Yep, now hit enter. There it is. I think you might have missed an entry. This should be it. Your entry code is incorrect. But do you see how it takes a lot of time to go through and type those in? Whereas as you learn how to do this, it's real quick. Okay? So let's try another one.
Mr. Murphy.
Yes, sir.
So we're gonna have like, this is where we can use a calculator, we just do that, and then we're gonna have another one where you can't do it, you have to do it by hand.
Yeah. Calculator, non-calculator. You will see lots of that as we go along. Yes, sir.
I had 7254.
Are your entries incorrect? Or did you do B times A?
Got it.
You will get a different answer if you go B times A versus A times B.
Yeah, I think I messed that up.
Because you're going, when you're multiplying matrices, it says A to B, you have to go A to B. Otherwise, you go the other direction, you're multiplying different rows and columns. We'll get to that. All right.
Like
I know it takes a minute or two, but you'll be all right, trust me. Once again, we have a square 2 by 2. -6, -2, 0, 3. -1, 4, -5, 3. And I'm going to follow the exact same pattern of 2 by 2 times a 2 by 2. We're not going to push into the higher stuff yet today. And we're going to write it as, remember, say I got 2 columns, I'm going to write that first matrix twice. -6, -2, 0, 3, -6, -2, 0, and 3. Now I start filling in what it's being multiplied by. -1, -1, -5, -5, 4, 4, 3, 3. And in between all these things is an addition symbol. Our result matrix should be a 2 by 2 if we got somewhat lucky here. So we have 6 plus 10, 0 and -15. Would somebody try and put that in a calculator real quick just to double check us here? -24, -6, and -30.
Did you get 16, -30, -15,
I did. And you did it right. Or we both did it wrong.
wait.
Which means we did it right. Yes, sir.
How do you get the numbers in?
Okay. Are you okay with writing down this matrix twice? Because there's 2
Yeah.
columns.
I got
Now,
that part.
What's weird is that you have to go in a different order. This is the first one, second, third, fourth.
Oh, I see it now.
You're working your way down. If there were 3 of them, you'd go to the third one and then you go down the next column. It's rows by columns, and it's very weird if I try to say go this way, this way, this way, this way, as opposed to just setting up this jig.
If there's 3, do you write it out 3 times?
Yes, and we're going to do 3 by 3, so we'll do the 3s and stuff tomorrow. Today we're just going to do a couple 2 by 2s, because I think it's a fair stopping point. We've done the addition, the equations. Those are very, very easy. This is what's going to take a little bit more time. Okay? So let's get some problems to try for tonight. We'll stop here.
What is this time of the extra credit?
This, we're going to cut this apart here. We're going to change this up, this page 212. The 203 is going to be not a problem. The 15 through 35 odds. The 212 stuff, I'm just going to give you a couple of 2 by 2s to try. So this is actually a different page. So let me change this to page 211. I'd like you to do number 19 and 20. And that's it for right now. Those are 2 by 2s to multiply out.
That's it? Just 211?
Just, no, I want you to do those and those, okay? The 203 page, remember, that is mainly adding and subtracting, some scalar multiplication stuff. A couple of quick equations to solve for it. That should not take very long. I gave you odds so that we can check your answers, make sure you got them right. And then the multiplication ones, remember, they're both 2 by 2s. Follow the pattern that we just did in class.
have 2 problems?
For the multiplying out to start with, yes. Tomorrow we'll go into a little bit more of that. We may or may not get to 4-3. We might start determinants. Who knows? All right?
Plastic application.